Hello, everyone. I'm pleased to be here today to have the opportunity to talk about the concept of entropy. Entropy is actually one of the really important topic in uncertainty modeling. Of course, it has much more application in engineering, different fields of engineering. However, in our research group, we are more focused on entropy for uncertainty modeling. I am recording this video because I want to convey the research works we have done in our group to students, especially for those who are going to start working on entropy. By this way, then they don't need to start from zero. They at least can understand the concept and the main idea about the entropy, and after that they can further delve into their own research. And for those students that are currently working on the entropy, I just welcome them to reach out to me in order to discuss the research detail, and after that we can try to figure out what we can add to their research or handle their research challenges. Okay, let's start by the definition of entropy. So I will title the page here, the definition of entropy. Definition of entropy. Uh, for those guys who work on the probabilistic modeling, the reliability analysis, and of course, like uncertainty modeling, they are dealing with some sort of random variables. And when we want to define a variable as a random variable, then we need to think of the distribution function. And one of the most representation of the distribution function is probability distribution function, or PDF. So just let me draw a simple PDF here. Just suppose that this is going to be a PDF that is the EX, and here is the PDF probability density function. And let's draw it in this way, for instance, something like this. So this is, I can call it PX, or the PDF of X. So here in this case, X is our random variable, and this PDF is the probability density function. What we are seeking right now is the entropy of a distribution, entropy of the distribution. In fact, it's a really simple definition. Let me show the entropy by H. So what I'm going to calculate is the H, or the entropy, for this distribution here. So I just put here the H of P. As the definition, it will be defined as the integral on the X for Px times the log of Px. So as a definition, the entropy will be defined as the multiplication of the P, which is the PDF, times the log of the P. And then we do an integration over the whole domain, and then we calculate the HP, or the entropy. But usually, generally speaking, there will be also a negative sign here, the minus sign here. The reason is because later we will try to optimize the HP, or the maximize the entropy. But when we put the minus sign here, then we can, instead of optimization, we can go through minimization. So this is something that can help us to do the optimization. Well, we can keep to the definition and just put this minus sign here also. This is for the continuous form of the distribution function. If we are dealing with the the discrete form, then we can define the HP in this way. HP equals, let me put the minus sign here, the summation of PI times the log of PI of P. Let me write it better. PI. So this is gonna be the definition of entropy when we are dealing with the discrete distribution. So based on this definition, then if we are given a distribution function, any type of distribution function, we can actually calculate the entropy for that specific distribution function. Let us go through a MATLAB programming in order to understand how we can implement this formulation. That means if I give you an a distribution, you would be able to calculate the entropy. So I will open up the MATLAB environment. We are in the MATLAB environment right now, and we're gonna start programming. I will first make a function to help us calculate the entropy. And then after that, whenever we need this function, we can simply call it. So let's start by making a function. In order to make a function in MATLAB environment, it's easy. We can just simply type function, and then the output of the function, that I'll call it here y, for instance, and then we choose a name for the function. Here, in order to make the name meaningful, I put, for instance, entropy underscore approx. And then we're gonna specify the input of the function. For that, first of all, is the distribution function. I'll call it, for example, f. And then we need to specify the lower and upper limit of this function, because when we're gonna calculate the entropy, we need to take the integral from a lower to the upper limit, or simply when we have a distribution function, we need to specify the lower and upper limit of this distribution. So let us call it lower and upper. Lower and upper. I need one more thing, that is the parameter of this distribution function. For instance, when we have a normal distribution, we have the mean standard deviation, or any distribution function has some parameters. Let's call them, for example, var(n). So I'll put an n for this function. And right now I need to write down the main body of the function. So we're gonna calculate the y. This is gonna be using an integration, right? So it is an integral of a function. So I use the add sign. And right now we have the function f with the variable x and some parameters that come with this var(n), right? var(n). So as many as parameter would be fine for us. Okay, and this one times the log of this one, right? Exactly the log of this function f. From a lower limit to an upper limit. I think this is gonna be enough. I just save it. Just make sure that the name of the file is the same with the function, okay? Save it here, then I make a new script and then start our main program. Here, let's, for instance, start by calculating the entropy of a normal distribution. So let's say a standard normal distribution. So I put the mean of the distribution as 0, and then the standard deviation as 1, and then go to calculate the entropy of a normal distribution. We're gonna use the function we wrote. So the name of the function is entropy approximation. We're gonna start by giving the PDF. So I again put at sign x. That's going to be a normal PDF. The variable is x, and the parameter of the distribution function are p mu and a standard deviation and p standard deviation. Okay, what would be the lower and upper limit of this function? This is let's for instance put 10 standard deviation before and after the mean. That's going to be a good point, a good thing. So p mu minus 10 times psd going to be the lower limit, and then p mu plus 10 times psd gonna be our upper limit. So I think it's enough. Let us save it and call it app1, and I do run the code, and as you can see here, the entropy of this function is this one, 1.4189. If I go to the definition of this entropy, I can simply put a minus sign here in order to make it the same with the PPT, or we can just leave it as it is. Anyway, by this way, we can literally calculate the entropy of any desired distribution function. As another example, for example, we can calculate the entropy of an exponential distribution function, for example. So let us first determine the lambda, which is the parameter of an exponential distribution function. Let us, for example, put it as 2, and then calculate the entropy of an exponential function. We can again call over the function that we wrote, that is entropy underscore approximate. So we're gonna have a new PDF that is exponential PDF. So our variable is x and the parameter is 1 over lambda, right? So we're gonna specify a lower and upper limit. Let's for instance put it 0 to 100. So with this one, we're gonna have the entropy for the exponential equals to 0.3069, while the one for the normal distribution was this one here. Okay, that's all for this session. In upcoming sessions, we will be talking more about entropy and then the application of entropy in uncertainty modeling.